When we are trying to determine whether a solution is acidic or basic, we can use different chemicals that can be added to a solution that will provide a visual indication of whether the substance is acidic or it is basic. And what these indicators are usually themselves weak organic or base acids or bases, and they're chosen because their acidic and basic forms have different colors from their conjugates, and so they are easily distinguishable depending on what pH range they're in. Now, not all acid-base indicators turn different colors at exactly a pH of 7 when something's acidic or basic. Sometimes they'll have a color change within the acid range or within the base range, and this makes them particularly useful if you are trying to work in a given. There are lots of different chemical indicators that can be used to identify whether we have an acid or a base, but there are some fairly common ones that we come across on a regular basis. Many of these indicators will change color at specific pH ranges, so depending on the experiment that you are looking to do, if you are looking for a change to be occurring at a certain pH, you would choose your indicator very carefully based on a substance that would make that color change at your desired pH. But typically there are some common ones that we use when they will transition right around the neutralization point of pH of 7, because oftentimes that's what our titration type lab experiments are looking for. When have we added enough of our titrant to neutralize the analyte? So one of the most basic chemical indicators is litmus. Usually this comes in the form of strips of paper, and they usually comes in pairs, red litmus paper and blue litmus paper. And the positive thing about litmus paper is it's a very easy test. You dip it into the solution or take a little bit on a stirring rod and place it onto the litmus paper, and depending on the color that it changes, it will tell you whether you have an acidic solution or a basic solution. The drawback is it doesn't tell you how acidic or how basic. It is pretty much a qualitative acid-base test, not a quantitative acid-base test. Phenolphthalein is probably one of the most, if not the most, common indicator used when working with acid-base neutralization reactions. Phenolphthalein indicator, when a few drops are added to your analyte and you undergo the titration, it will be colorless in an acid solution, but in a basic solution, and actually the pH transition is between 7 and 8, pH of 7 and 8, but it will turn a bright hot pink color. And typically what we look for when we are titrating using phenolphthalein is the point at which we get a persistent faint pink color. Sometimes we can also use Bromothymol Blue as an indicator. Bromothymol Blue will be yellow in acid, acidic solution, low pHs, but a blue color in higher pHs or a basic solution. And then there's an indicator known as universal indicator, and this is actually a combination of several different chemicals that color transition at different pHs. So it sets up a spectrum of color changes, and it allows you to get a more quantitative reading rather than just one pH change, there's the color change, this is the pH we must be at. With universal indicator you get a little bit more broader ability to quantify exactly where your solution might happen to be. In a neutral solution right around pH 7, universal indicator is going to be a greenish color. At low pHs, representing an acidic solution, it tends more towards the red end of the spectrum, while on the higher end, the higher pH values indicating more basic solution, universal indicator turns more of a deep violet or purple color. Now the limitations of these indicators is that the solutions you're testing should be colorless in the first place, because since your determination of acidity or alkalinity is based on the color that you see, you won't have a neutral background. The other drawback is the ability of the human eye to be able to distinguish between slight changes in color, and so you you can't get a quantitative measurement, or at least a very accurate quantitative measurement of the pH simply by sight alone. And the other limitation is that these pH changes usually occur over a very, or color changes occur over a very small pH range. So when you are titrating, which is typically where we use these indicators, you have to be very careful how much of your stock solution you're adding to the unknown so that you don't miss the transition, because a lot of times the transition, for instance with phenolphthalein from colorless to pink, can take place with a single drop. And so if you are adding your stock solution too quickly, you can blow right by that endpoint, and that will throw off your concentration calculation, and your pH value will spike in a matter of just a few drops.